Okay, here's an example problem on subnetting. And it says a host computer is assigned an IP address 192.168.10.115 with a subnet mask 255.255.255.192. And it wants to send a packet to another computer with IP address 192.168.10.215. And so the question is this destination IP address on the same subnet as our original host? Why or why not? And this is the host routing decision that every host has to make when sending a packet. Should it send it directly to the recipient if it's on the same local area network, or should it send it to its gateway router if it's not? And so let me show you how you can do this problem, and I'm going to show you several different ways. The first way I like to do, well, the first thing I'm going to do is I'm going to notice that 192 implies that this is a Class C network, and that implies that the number of network bits is 24, the first 3 octets. Okay, 192.168.10. Okay, but when we have this mask, 255, 255, 255, 192, that mask, the bits in that mask essentially answer the question, yes or no, 1 or 0, do the bits need to match? Do the bits of the IP addresses need to match? And so the 255s are all 8 ones in a row. The 192, though, is 128 plus 64, meaning that 192 is 11000000 as a byte in binary. We've got a 1 in the 128's place, a 1 in the 64's place, and zeros at all the other places. And so what this means is that, and then the number of bits, the number of ones in the mask is equal to n plus s. And we have 8 bits of ones in the first octet, 8 in the second, 8 in the third, for 24 total ones. With the 192, we get two more ones. And so this is 8 plus 8 plus 8 plus 2, which is 26. And that therefore implies that the number of bits that have been taken from the host addresses to use for subnet masks is 2. Okay? So without subnetting, we have n is equal to 24 and h is equal to 8. 24 plus 8 is 32 for the full length of the IP address. But now with subnetting and with this mask, we have 2 bits taken for the subnet mask. So S is 2, and now H is just 6. 6 plus 2 is 8 for that last byte. And so the number of subnets is 2 to the S, which is 2 squared, which is 4. And the number of IPs per subnet is 2 to the H, which is 2 to the 6th, or 64. And basically, what we're doing is we're taking what was an H equals 8, or 256 IPs in a Class C network, and we're taking those 256 and dividing them into 4 groups of 64. 4 times 64 is 256. 2 to the S, 2 to the H is 2 to the 8th, which is 256. Okay, and so if we're going to divide that space into 4 groups of 64, and everything is happening in that last octet of the IP address, we can write down the subnet IP ranges. Okay, what I'll do is I'll start with the subnet ID. I'll do the first IP in the subnet. I'll do the last IP in the subnet, and I'll also do the broadcast IP in the subnet. And you're going to see it's pretty straightforward. Once you figure out that S is 2 and that we're working with just the last octet, and we're working with a space of 256 IPs. We start with 192.168.10.0, and then we move to .64. We count by 64s basically. Okay, when you have 64 IPs per subnet, we're going to count by 64s here. We're subnetting a class C. The broadcast now is one less than the start of the next subnet, or the ID of the next subnet. And so the broadcast for subnet number 2 is .127. Broadcast here is .191. And finally .255 is the highest one that we have available. And now we can fill in the first and the last IP. The first one is one more than the subnet ID, and the last IP is one less than the broadcast. .62.126.190.254.1.65.129.193. Okay, so now what we can do is we can look to see whether or not our two IP addresses, 115 and 215, are in the same subnets. And it turns out that 115 is in this range, and 215 is in this range. 115 is in between the 65 and the 126, and the 215 is in between the 193 and the 254. And so this implies that IPs .115 and .215 are on different subnets. Okay? And this is how I would solve this problem myself the first time through. I'm going to leave this video as it is, and then I'll do some more. I'll do one or two more videos showing you alternative methods and equivalent methods of solution. So basically, when I look at this, I can see a 192, and since it's a class C, I know we're only working within the last byte for our IP addresses, and we've got a space of 256 IP addresses we're working with. And when I see the 192, I know that that's 2 bits, and that I'm using 2 bits for the subnet, 6 for the host, 4 subnets, 64 each, count by 64s here in the last octet, get my ranges, and see whether or not my IPs are in the same range. Okay, hope that helps.